And how do you handle actually like a training, monitoring, and debugging in a context of, of training these foundational models? You've mentioned that, well, however efficient use of the GPUs is important, there are other kind of overarching goals of actually delivering something of a high, well, let's put it accuracy or any like other metric, but like to drive improvement. But how you actually monitor the training?
We monitor loss values per data set. So that's then mainly about pre-training. Even if the usability and user satisfaction can also depend a lot on the other part besides pre-training, we still believe it's really important to track just a simply perplexity loss per data set, which also defines like some sort of a fine-grained view, shows the fine-grained views of performance per task, because we have a data set per like different areas or different sources and different materials. And for the sake of the pre-training, that's still very meaningful to monitor, no matter how noisy it is. And we use 1DB on that. And then the evaluation we are now working on like right now is to implement asynchronous evaluation. So essentially just allocating some compute resource and then run some evaluation that involves some of the popular benchmark as well as some of the internal benchmarks that we have. That is basically some biomedical drug discovery tasks that went to. So on that, we created this eval data set with the team who actually has the knowledge of something about bio, not like me or my team members. And then we run it. We will run it more often and more in automated fashion, so that we can make sure things are going well. The thing is, it is all about pre-training, and then during the post-training, which I think now are gonna spend more time. It's really hard to evaluate the result. Of course, we can train on the benchmark, but that doesn't really, tell us the big picture about the performance, user satisfaction. So we have, although we are not biologists, now we have everyone has some set of the problems that they can use in the vibe check that requires biomedical knowledge, and yeah, we now sort of know at least the answer for those questions, and something like for antibodies, something about cancer treatment, something about very basic biological concept and problems, and then we use it. So basically, vibe check, but with the domain-specific questions and knowledge. Still vague, so eval is still a big part of the problem.
And still quite a lot of a human kind of in the loop. And I guess it's for that domain, we can still foresee that there will be quite a lot of a human in the loop still for a while.